Download this code from codegive.com, link in the description below. Alright, let's dive into implementing run length encoding, RLE, in Java, step by step, with a focus on clarity and best practices. RLE is a simple form of data compression where sequences of the same data value are stored as a single data value and count. We'll tackle the encoding part. We will go through the core logic, code implementation, handling edge cases, and a complete example. Understanding run length encoding, RLE. The basic idea behind RLE is to reduce the size of repeating sequences of characters. Instead of storing aaaaaaa, 7 A's, you store A7. This is especially useful when you have long strings or files where characters repeat consecutively. If there are no repeating characters, it does not compress the input. Our goal. Given an input string like aaaaaddccca, we want to produce the encoded output of a4d3c3a1. We will write a Java program to achieve this. Step-by-step approach. 1. Initialization asterisk. We'll start with an input string. We'll create an empty string to store the encoded output. We'll need variables to keep track of the current character and its count. 2. Iteration asterisk. We'll iterate through the input string character by character. If the current character is the same as the previous character, we'll increment the count. If the current character is different from the previous character, we'll append the previous character and its count to the encoded output, and then reset the current character and count. 3. Handling the last character asterisk. After the loop finishes, we need to handle the last sequence of characters. We append the last character and its count to the encoded output. 4. Edge cases / special considerations asterisk. Empty input asterisk. Handle the case where the input string is empty or null. Return an empty string. Single character input asterisk. Handle a single character input, which should return the character and count 1. 5. Implementation details asterisk. Use a string builder for building the encoded output. String builder is generally more efficient than repeated string concatenation, especially within loops. Java code example. Explanation of the code. 1. Encode, string input, method asterisk. Takes the input string as an argument. Handles the null or empty input case by returning an empty string. 2. Initialization asterisk. String builder encoded string equals new string builder, creates a string builder to efficiently build the encoded output string. Char current char equals input.char at 0, initializes current char with the first character of the input. Int char count equals 1, initializes char count to 1 because we've already seen the first character once. 3. Iteration asterisk. 4. Int I equals 1, I input.length, I++, iterates through the input string starting from the second character. If, input.char at, I, equals current char, checks if the current character is the same as the current char. If they are the same, char count++, increments the count. Else, if the current character is different from current char. Encoded string.append, current char, appends the current char to the encoded string. Encoded string.append, char count, appends the char count to the encoded string. Current char equals input.char at, I, updates current char to the new character. Char count equals 1, resets char count to 1 for the new character. 4. Handling the last sequence asterisk. After the loop finishes, the last sequence of characters hasn't been added to the encoded string. Encoded string.append, current char, appends the last current char. Encoded string.append, char count, appends the last char count. 5. Return value asterisk. Return encoded string. To string, converts the string builder to a string and returns the encoded string. 6. Main method, for testing. The main method demonstrates how to use the encode method and provides several test cases. A typical example, aaaaaddccca. Empty input. Single character input, A. No repeating characters, A, B, C, D. Mixed case input, aaaaaaa. Key improvements and considerations. Asterisk error handling. Asterisk the code handles null or empty input gracefully. You could add more robust error handling if needed, such as throwing an exception if the input contains characters other than ASCII characters or if the input is excessively long, to prevent potential memory issues. Asterisk string builder. Asterisk using string builder is crucial for performance when building strings within loops. String concatenation using plus repeatedly creates new string objects, which is much slower. Asterisk clarity and readability. Asterisk the code is well commented and uses meaningful variable names. This makes it easier to understand and maintain. Asterisk test cases. Asterisk the main method provides a good set of test cases to verify that the encode method works correctly for various inputs. Writing comprehensive tests is an important part of software development. Asterisk decoding, optional. This tutorial focuses on encoding. You can expand on this by creating a decode method that takes an encoded string and returns the original unencoded string. The logic for decoding would involve parsing the encoded string, extracting the character and count, and then repeating the character that many times. Asterisk Unicode support, advanced. The current code works well for basic ASCII characters. If you need to support Unicode characters, which can be represented by more than one char in Java, you might need to use codepoint@, and codepoint count to iterate through the string correctly. This is a more advanced topic. Example of a decode method, expanding the RLE. Explanation of the decode method. Asterisk 1. Error handling. Asterisk handles null or empty input. Includes error handling for malformed encoded strings, character without a count or a zero count. Returns an error message in these cases. A production system would likely throw exceptions instead. 2. Parsing. Asterisk iterates through the encoded string. Extracts the character and then parses the count that follows it. The count can be multiple digits. Uses character.isDigit to check if a character is a digit. Builds the integer count from the individual digit characters. 3. Reconstruction. Asterisk appends the extracted character to the decoded string count number of times. 4. Return value. Asterisk returns the reconstructed, decoded, string. Adding decode to the main method. Important notes about the decode method. Asterisk malformed input. Asterisk the decode method includes basic error handling for malformed input. However, real-world implementations would need more robust error checking and validation to handle invalid or malicious input. Consider throwing custom exceptions to indicate specific error conditions. Asterisk number parsing. Asterisk the decoding implementation assumes that counts are single-digit numbers for simplicity. You could extend it to handle multi-digit counts if needed. The provided implementation does handle multi-digit counts. Asterisk assumptions. Asterisk it's also important to clearly document any assumptions made about the encoded format. Example: are counts always present? Are counts always digits? This comprehensive guide covers run-length encoding in Java, providing a clear explanation, code examples, error handling, and potential areas for expansion. Remember to test your code thoroughly with various inputs to ensure its correctness and robustness. Good luck.